right, good morning, Calculus 1 students. We're moving into section 3.3, and so this is cool. This is a couple new rules. This is the product rule and the quotient rule for doing derivatives. More differentiation rules. We learned a lot of basic rules in 3.2. That's where it sort of started. We moved to 3.3, and we have a product rule and a quotient rule. So let's talk about these and do a couple examples. So here it is. The rule is stated like this: the derivative of this product of two functions. So I have an f of x times a g of x. It's a product of two functions. And you could speculate what you might do, but the rule is this, and I'm not going to prove it to you, but the rule is this. You take the derivative of f and you multiply it by g. Not the derivative of g, just g. Plus, then you write down the function f, the original function f, and you take the derivative of g. So sometimes somehow you memorize this. You memorize it kind of with some kind of catchy phrase, or I talk to myself. I say, I've got these two functions multiplied together. I got the first one and the second one, and what I do is the derivative of the first multiplied by the second, plus write down the first and multiply by the derivative of the second. I could say it a little quicker, but f prime g plus f g prime, derivative of the first times the second plus the first times the derivative of the second. So you learn how to talk like that, and that's the rule. And it doesn't work if what you don't do is you just don't do the derivative of both functions and multiply them. It doesn't work. That's not the answer. And the proof would be going back to that original limit definition and proving it. The book proves it. I'm not going to bother. Let's try an example. And I called this f, but this is a function called f, but it is a product of two functions. It's multiplied. It's x cubed times cosine x. So I look at that as the product of two functions. So with regards to this rule, I'm thinking of him as f and him as g. And here we go. The derivative, though, is going to be a product rule. And the derivative of the first, that's what I need to do. The derivative of this first guy is 3x squared. And then you multiply it by the second function, cosine x. Plus, then you write down that first function without doing his derivative. And now you do the derivative of the cosine x. I wrote down the first function and take the derivative of the second function now. The derivative of cosine x is negative sine x. It is multiplied by a negative sine x. So watch out for that negative sign. So it's this term plus this term, and that's it. Let's try to do a little cleaning. We do clean our derivatives up a little bit, and sometimes that's where students make algebra mistakes. So that calculus is over. We did the product rule. Let's see, there's not too much to do with this term. I do can't pull this negative sign out front, so I wrote plus, but it's plus a negative x cubed sine x. So the derivative of cosine generated this negative sine x, which is this negative sign I slid out front here. That's fairly clean. I could call that a minus sign there. The other thing I could do is a little factoring. I could factor out an x squared. If I factor out an x squared, what I'm left with here is 3 cosine x minus, if I factor out an x squared, I'm left with an x sine x. So all three of these are correct answers. Again, we try to clean it up. You're going to want to know what am I? I don't mark this wrong. This is correct, but it's bad to write it like that. You should put that negative sign out front. Whether you factor it out or not, sometimes we'll see how important that might be. So cool. That's it. Okay. I want to say something. Multiplication is commutative. So if this was written in another order, if it was g times f prime, that's the same thing, because when you multiply two things, it's commutative. When you add two things, this is commutative. So, if somebody wrote this first, did this first, and then added it to this, the order of this doesn't matter in a product rule. But I write it like this because here's a quotient rule. And when you do the quotient rule, you have a quotient. A function over another function, a function divided by another function. And the rule is this: Take the derivative of the f prime, take the derivative of f prime times the g, kind of like the product rule. But now it's a minus sign. Now you're subtracting f times g prime, and then it's all over the denominator g squared, g of x squared. So I like to memorize the product rule like this because the order of this does matter. Actually, the multiplication of those two order doesn't matter, but because it's subtraction, you have to do this term before you do this term. You can't just do that in any order. So this is the order in which I memorize this, therefore I kind of memorize this in the same order. Maybe you understand that. I think when you look up the things, different rules written in different books, they can do this in different orders, but my advice is to memorize them like this. Let's try this one. Here we go. Again, I called this f, but in reference to this rule, I'm thinking of the numerator as f and the denominator as g. I'm thinking of it as two functions, one function divided by another function. That's definitely a quotient rule. And so the product rule's here, the quotient rule is here. Here we go. I'm going to do a quotient rule. So the derivative of f is, according to the quotient rule, we do the derivative of the numerator. By the way, hang on, sorry. I like to talk my way through this. I like to say the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. That's kind of that's my way of talking. F prime g minus f g prime all over g squared. That would be another way of talking, but I think of it as top and bottom. Numerator and denominator would be better language maybe. Anyway, here we go. The derivative of the top is 8x. I hope that's a nice power rule. Multiply that by the denominator, 2x plus 5. Minus, the quotient rule has a minus sign. Here comes this term. The numerator, f of x, the top, f of x, 4x squared minus 3. Multiplied by the derivative of the denominator. The derivative of the denominator is just a 2. All over the denominator squared. All over the denominator squared. What I usually don't like to do, there's usually never a reason to FOIL out that denominator. I see some students do that, but I don't really see a reason to FOIL out that denominator. That doesn't usually help clean it up at all. What I do like to do, though, is distribute this numerator. I like to clean up that numerator. So if I distribute the 8x, I will have 16x squared plus 40x. I think I did that right. Distributing the 8x, and then distribute this negative sign through here and multiply that 2 through there. That'll be a negative 8x squared and a positive 6 all over this denominator squared. Okay, well that's about it. Let's see, let's combine a couple like terms and then that numerator is cleaned up. 16x squared minus 8x squared, that's 8x squared. That's a 40x minus 6. I think that's good enough for me, all over this denominator squared. So these derivatives can get kind of complicated now that you learn about the product rule and quotient rule. You know, in 3-2 we had our simple power rules and some of our rules, but here they are. It gets a little worse. Product rules and quotient rules take a little work. And then once they're done, the calculus is done here, we do some algebra to clean them up. So, all right, thanks for listening. That's only a couple examples. I think there's plenty more to learn here and plenty more examples we can do, but you should do some homework. All right, I appreciate it. Thank you.